Now we have a short video clip on the visit on this FIUSIS plants that was carried out yesterday.
FIUSIS bioenergy plant started operation in 2010 by commissioning a megawatt cogeneration plant aimed to transform 10,000 tons of pruning residues per year into 8 million kilowatts per hour of electricity and heat. It is a good example of clean energy production from a renewable source available locally, due to the close connection with farmers and agricultural contractors for the recovery of olive tree pruning residues. The industrial site includes a storage area where the wood chips obtained from olive tree pruning are accumulated and moved to aerate them in order to reduce the humidity of the biomass and increase its calorific value, also limiting its degradation by fungi and molds. The images show an overview of the storage site and the machinery that performs these operations. The actual biomass energy conversion plant is based on widely used and tested technologies. An automatic feeding system with rakes and conveyor belt brings the wood chips into a recovery boiler with a moving grate burner from Unique Comfort, an Italian company that has established itself on the international scene for its high level of efficiency and reliability. The boiler burns in constantly controlled conditions, 24 to 28 tons of wood chips per day, and the heat generated by the combustion of the biomass is recovered by a system of diathermic oil exchangers and used for the cogeneration of electricity and heat in an organic ranking cycle unit of the Turboden company, with an electric power of 1 megawatt based on a turbo generator to transform thermal energy into mechanical energy and finally into electric energy. Instead of generating steam from water as a conventional steam turbine, the ORC system vaporizes an organic fluid in a closed cycle system, which allows to operate at lower pressures and no erosion of the metal parts and blades. All the electricity produced is fed into the national distribution network with priority for a line that directly feeds the city of Calimera, which can thus be boast of being the first city in Salento and one of the first in southern Italy for be powered by renewable energy. In addition, heat generated in the ORC unit is recovered and used for pellet drying in a production line built at the same site, further improving the overall efficiency of the biomass energy conversion process. Lastly, particular attention was paid to the reduction of polluting emissions and in the first place of fine particulate matter, which are drastically reduced through the use of a high-efficiency filtration system through which the fumes leaving the boiler are conveyed. Final emissions of particulates are equal to 1 milligram per normal cubic meter, compared to the maximum limit of 30 milligrams per normal cubic meter set for this type of plant. This result is even more important if we consider the fact that before being used in the FIUSIS plant, the olive tree prunings were burned outdoors without any emission control. Moreover, future plans include a facility for turning the wood ash generated by the plant into high-quality fertilizer with a view to full implementation of the principle of the circular economy.
Okay, we have seen in this video a very short but clear description of the plant of the FIUSIS plant for producing energy from residual biomass. Now I have prepared a presentation in order to give some information about the framework in which we are carrying out our project and our activity. I'll try to be very fast in this presentation. In any case, slides will remain and will be available to all the participants to the meeting. So the aim of the branches project is to develop examples and chains for the growth of bioeconomy. Bioenergy is disappeared. Huh? Okay, bioenergy is a pillar of bioeconomy. At present moment, the most important use of biomass, not for food, obviously, industrial use, no food use of biomass, is the production of energy. Concerning the Italian situation, if you have a look, you can see the real way of bioenergy compared to other the other renewable sources. And it's we have to consider that the name given to bioenergy is the overlooked giant of renewables. Bioenergy is really a giant in the context of renewable energy sources. Why? It accounts for around the half of the total contribution of renewables to energy consumption. In Italy, is less. Is about 10% of the total energy consumption, final energy consumption in our country. We all know what is the importance of bioenergy, and a point to consider is that bioenergy is able to cover any kind of request for energy in a modern society, with different weights depending on the final destination. For the production of electricity, bioenergy is only a minor contributor. But if we consider the production of heat, bioenergy is the largest energy sources, and this is particularly relevant because the thermal consumption are about the half, the 50% of the total energy needs. Please. Okay. Concerning with the production of electricity, this is a list with the number of plants at present running in Italy. The plants like FIUSIS, fueled with wood and biomass, are less than are near 400 plants. But another interesting consideration is that the use of bioenergy in the domestic use, in the domestic heating. As you can see, biomass in Italy, but the situation is not so different for the most of European countries, is the second energy source, energy carrier, in soon after the natural gas, and more than electricity and other kind of other energy sources. I said the situation is quite similar in other European countries. You can see that the level, the amount of energy produced from biomass produced and consumed, obviously, from solid biomass in some European countries is quite similar. Next. Obviously, we have to compare the data from a previous slide to the total amount of energy consumption in different countries, and depending on the weight, the dimension of the use of biomass use for heating, you can see that the percentage of renewable renewable energy sources on the total consumption of energy can be also very relevant, as in the case of Finland that I pointed, where renewables in the thermal, in the heating sector are more than 50% of consumption. Okay, we know that bioenergy has a lot of strength points, and it depends obviously also from the wide variety of possible biomass raw material from different sources. Just a very short consideration about the Italian situation. If you look at the last point, you can see that we have a good forest heritage, but we use less than it would be possible the annual production of biomass from our forestry. And just for finish this very, very, very fast presentation, I would show some consideration about the question of sustainability of biomass. If we use a biomass fuel, the reduction of CO2 emissions, that's the same that the contribution of bioenergy to decarbonization, depends not only by the amount of substituted fossil fuel, but also, obviously, by the production of the CO2 emission due to the chain for harvesting, conditioning, and transport the biomass. In such a perspective, is very, very important the role of mechanization, because in several cases it can be the difference between a good level of sustainability of the chain, of the supply chain, or not. This is a very complex graph, and I would only note that in future, but till now, in the next year, if we consider the real sustainability of a biomass or bioenergy supply chain, we have to perform very high CO2 emission savings. And a fundamental issue is the distance from the place in which biomass is produced and the place in which biomass is converted to energy. That's because why the examples like FIUSIS plants are very important for the future of bioenergy. In order to win the challenge of sustainability of the whole chain from the field of the forest to the conversion plant. An element, a very important issue for in order to reach this general objective is to find and to share examples of good practice. Is one of the most important targets of Branches project, because a good example, like the list of practice habitats that we have selected till now, are is possible to repeat and to copy in similar condition from a country to another country. During this showcase day, we have to present and discuss some of the selected practice abstracts. You saw some during the previous sessions, and in particular, we have selected for this workshop 4 Italian and 4 practice abstracts, examples of good practice from other European countries. And now I'll introduce directly an example of this practice abstract, and would invite Robert. Sorry for my site. I will invite Robert to explain the to show the content of their experience. Please, Robert.
Thank you very much. So just a few notes at the beginning. So I'm presenting this practical abstract on behalf of our other Finnish partner, VTT, the Technical Research Center in Finland. So they have been behind this practical abstract. And the title of the abstract, it was just there, yes. Biochar production and heat generation through slow pyrolysis. So as I mentioned, I'm not the expert exactly on this kind of topic. Our colleagues from VTT are the experts on that. So let's see if I can answer your burning questions, but I try to explain now this as good as I can. So it is a case on the company Carbofex from Finland in Tampere, and it's about pyrolysis, slow pyrolysis, to produce biochar. So the pyrolysis technology turns existing biomass into biochar, oil, and gas in very high temperatures and the absence of oxygen. So this is the principle of slow pyrolysis. And Carbofex has a demo plant in Hiedenranta in Tampere, established in 2017. And it's also a technology provider selling turnkey solutions for this kind of technology. So such a plant can produce 700 tons of biochar and 600 tons of oil annually. The specific unit carbonizes up to 500 kilowatt of wood chips. So the input, the raw material are wood chips, turning it into 140 kilograms of biochar. And since that is a very good thing, the facility produces more energy than it consumes. So basically we can use this energy then for other purposes. So this is how it in principle works. The Carbofex decarbonizer is a continuous operating unit. And well, it starts from the hopper and then goes through the processes uniquely controlled. And basically the temperature and resistance time can be accurately adjusted to the resulting biochar. So making sure that we have a final product that is uniform in its quality. And the next one, please. As I mentioned, the feedstock, the raw material is wood chips. So the demo plant uses wood chips from small diameter trees, and in particular from spruce thinning. So this is quite common raw material, and it's very good that we can use this kind of raw material because we have plenty of that in Finland growing. So the wood is brought from private forest owners mainly. We have the biggest forest owners are private owners in Finland, so it comes mainly from that end. And but basically, in principle, this kind of technology works for any kind of other feedstocks, biomass such as olive pits, olive cake, peanuts, pine nuts, hazelnuts, pistachios, straw hulls, waste wood, date pits, palm kernels, coconut shells, you name it. So, of course, in Finland we use what we have there, so it's wood chips, but it could be used for any kind of materials. And the next one, please. So, as I mentioned, it can produce quite pure and high quality material. Carbofex is the biggest EBC certified biochar producer in Europe, so it's big. And there are multiple uses for biochar. So basically it can be used as a growing media in parks, in gardens, greenhouses, agriculture, which is very good. It can be used as water filtering application. We know char can filter water. And of course, CO2 from the feedstock is bound into biochar. So it's a CO2 binding process. So as I mentioned at the beginning, in addition to biochar production, the process generates oil and gas. And the pyrolysis gases are then recycled and used to energize the pyrolysis reactor. So basically the heat needed is used, and the excess heat can be used for drying wood chips before the process. So making sure that it's self-sustainable. And sorry if you stay still on that one. Just a second. Yeah. So as mentioned, it produces more energy than it consumes. So basically the energy is sold to external users of energy. And the excess heat from Carbofex, it is mainly going to the local district heating, which is the most common heating system. Also, a 1 megawatt heating boiler is attached to the unit, and that is connected to the district heating network. So thereby making the whole circle working. So this is a good example, I think, from Finland. And thank you, VTT, for providing this, and the company Carbofex. And with that, I hope it can contribute also or give an option for other countries, and we can use this or can see this kind of technology elsewhere. Thank you.
Thank you. Thank you for your presentation. Just a curiosity, but it's correct to say that your technology is a sort of pyrogasification because you produce also syngas, no? Okay. No, it's very interesting technology for producing a very innovative form of solid biofuels. Thanks again. So now we'll have two short presentation from the companies involved in the realization of these FIUSIS plants. And I would invite now immediately for his speech Dr. Zinetti, CEO of Unicomfort. That's the company that's that has produced the boiler of this plant, and then soon after Mr. Guidoni from Turbolen. Please.
Thank you for the speech. Apologize for my delay. I think if we need further example that climate change is happening, we had the airport of Brindisi closed for fog this morning. So I guess that's the best example that climate change is happening, and then we need to take action against this. I thank you for the invitation and for the organization. I want to thank especially Marcello, personal thanks to him. Marcello is a very visionary entrepreneur. We followed with him all the steps of this project. And I think Marcello was very visionary because he could combine how to make business while taking concrete action also towards the sustainability of our planet. He was also very perseverance in making the project. He had to face and win a lot of different obstacles that he had during the process. And also I have to give credit to him that he was able and very fast in adjusting the business plan of his project with changing environments that have changed over the 10 years. So I give all my respect and friendship to Marcello, and as an entrepreneur, also all my respect. Very quickly, Unicomfort, as it was introduced, have supplied in this plant the boiler part. With the boiler part, we mean all the line starting from the storage of the biomass up to the chimney, that is including the boiler and the filtering parts. And we also made all the connection to the ORC, to the Turbolen machine that was installed over here. Briefly, I will go through three topics. One, what is Unicomfort, what is our mission, and then as I was requested, I will try to make other example of how we have implemented our mission in projects involving circular economy and sustainability. So Unicomfort, as said here, is a supplier of biomass boiler, or better, solid fuel boilers. Then we would see in the last slide why we make this differentiation. We normally supply plants starting from the storage silos up to the chimney. We have a production of boiler capacity in up to 30 megawatt in hot water, or 20 tons hour of steam. And also we have a specific division, which was the one involved in this plant here to produce cogeneration plant, where we go up to a size of 5 megawatt. What is the mission of Unicomfort? And I think it's very coherent with what we are discussing here. Our mission is to give a new life to wastes or to material that are not used or are at the end of the life of a production cycle. In Italian, we have a motto which is, I think, very comprehensive, which is il riscatto dello scarto, which is a little bit difficult to translate in English, but basically the idea is that we want to give a revenge or a redemption for what is a scrap or a waste of any type of production by giving a new dignity, giving them the possibility to be a source of fuel and to produce energy. So this is what we have done so this is our mission. So how do we implement this mission in different projects? So we have taken here five different examples of projects we've made, but just to explain how we try to implement this philosophy. So the first one, obviously, is the project where we are here. Here we are starting from the scrap, so from the prunings from the olive trees. That was a problem, a big cost, economic and social problem in dealing with this waste. And we give the new dignity by producing energy, electricity, and thermal energy, which has already been widely explained. Among the same line is the second project. This is also another project with the colleagues of Turboden that we have done in Chile. Here, the problem was the availability of rice husk. It's a project in Chile where they have a big amount of rice husk that was not used. And so the circular economy project was use this rice husk to produce energy, produce electricity and thermal energy at the same time, which are used in a plant to produce panel with rice husk again for the construction industry. The ashes coming out of this project are then used as a fertilizer on the land. So I think it's a very nice example of circular economy. Another example in the industrial field, so we said before that we don't make just cogeneration plant, is a plant in Nestlé, actually better known as a Nescafé line. In the Nescafé plant in Vietnam, another one we are making now in Mexico, we use the remainings of the production of the coffee to produce steam, which is used to produce the Nescafé again. So it's again usage of a material that before our implementation was just used as a waste with a very high cost of also of disposal of this type of waste. The other project, AB InBev, the last two, is a very similar in concept. AB InBev is one of the most important beer producer in the world. Probably is better known for the name of the beers like Corona, Budweiser, Leffe. So in AB InBev, they had a waste, which is the husk coming from the barley, from the production. This husk had no use before we were using this. They actually had a cost to dispose this waste. So our project is that we are constructing, is to use this husk to produce the steam that is needed again in the production of the beer process. The last example I wanted to take is more a classical one, but is another plant we have done with Turboden is in Ponte di Legno. This is a district heating. So we have a boiler that is producing electricity and hot water for the community, and is fed with biomass that is coming from the maintenance of the forest. This is another important topic. Forests many times are not maintained because they don't have a usage for this type of biomass. In Ponte di Legno project, we gave a usage for the forest residues by producing energy for the community. Thank you for your attention.
Thank you for the presentation. I have just a very short comment to the last slide. That's an example of flexibility. The technology is suitable for different raw materials and is in all these different cases a pillar for a complete sustainability of the chain, the industrial process, and the renewable energy production. Thank you very much again. And now let's go to Turboden.
Hello, everybody. I'm Alberto Guidoni, a sales manager of Turboden, and I in particular follow the biomass application of our ORC. And thank you very much to Itabia and also FIUSIS to be here. I'm very happy and very proud for the opportunity. And I'm here only for a brief speech in order to explain the point of view of a technology provider as Turboden. So this is a concept that already Mr. Pignatelli already explained very well some minutes ago, but I want only to say that in EU community there is a lot of space to develop different energy sources as renewable and bioheat, and also for the production of power coming from solid biomass, and especially combine these two production coming from the same source, that is the biomass as byproduct, in order to produce power energy and heat in a very efficient way. So the technology to do this is available, proven, and economical feasible. Turboden is on the market, born in the 1980 years. So we already installed more than 430 plants in more than 50 countries in the world. So we produce ORC system that exploit and recover basically a different type of heat sources, as for example geothermal, waste heat in the oil and gas sector, and especially in biomass, with the biomass application, in order to produce electrical energy and heat power. I want to be more specific for the CHP solution of our plants, because as you can see, we can also install plants that produce only electrical energy with an electrical efficiency, depending on the some situation of the plant, of the environmental, etc., can achieve an electrical efficiency of 30%. On the other side, we have the CHP plant, so that the ORC turbines that produce not only electrical power but also heat. In this case, the electrical efficiency is arrive on average around 22%. But what happened? That in this case we can use also the other 78% of the of energy in the form of heat, as for example hot water, overheated water, and also steam up to more or less 200 degrees. So is very important in order to install a very efficient plant. Have the possibility to install a CHP plant. This type of technology, so the combination of biomass boiler and ORC plant, is very flexible. So we can use very different fuels and produce multiple output. On the left side, we can see a lot of different fuels that the companies, as Unicomfort, that is one of the leaders of this market, can use. Is sawmill residues, for example, by product, barks, wood and dust, chips, etc. And on our side, we can produce electrical energy and heat power starting from 50 degrees, so at low temperature, for example, for greenhouse, fish farming, district heating, etc., up to 20 degrees. So we can produce also steam, also for the big companies, as for example chemical processes, pulp and paper, dairy, vegetable oils refining. So is a technology that is already present on the market, and that we can use in order to achieve a very high efficiency also in the production processes. So thank you very much, and these are my email and my telephone number in case you desire to go deeper in the topic. Thank you very much.
Thank you. Just curiosity, another. What's Alberto? Thanks, Alberto. What's the power range of your turbines.
We start from in the biomass application, we start from 0.7 megawatt electrical up to 5 and those 4 megawatt. In other application, we can arrive till 20 megawatt of electrical power supply. But are very, very big plants.
Okay, thank you very much. Bye. So, any question? If no questions, I'll leave my chair to the next chairman for the last session of this workshop. I invite Professor Massimo Monteleone. And now we have the fourth and last session of the workshop.